So this video is going to be all about debugging and errors in JavaScript. So everyone hits errors as part of programming. It is a part of it in the grand scheme of things. You're not doing things wrong if you're hitting errors. The key is to debug those errors. So to go through a process of trying to fix those errors. So you embrace the errors and you have a process in your head that you go through to try and isolate what's causing the error and fix it. And that's what we're going to do. So I have two projects here. I have this Pokemon app that is loading information from the Pokemon API that I have linked here. So it's this one, pokeapi.co. Except that was the working version. Here's the version that I've got. It's got all sorts of bugs, nothing showing up on the page. So we're going to use a checklist that I've written to go through and try and solve the bugs one at a time that are in this page. I also have a React application that has some working components, but has some broken components. Like this calculator doesn't seem to be working properly. So if you want, I'll have these projects, the broken versions, zipped up and attached to the canvas, so you can download them and go through this process of debugging, or you could even pause the video now, look at the checklist, and see if you can do the process of debugging without me walking you through it. So before we even get to that checklist and start trying to work through the errors in these projects, I want to talk about the types of errors that you will encounter. So there are 4 general categories that I have listed here in this Canvas page. One are compile errors. So this type of error is one that comes when you have a build step. So when we have our create React app project running, it uses the software called Webpack to compile and bundle our code. And if there is a problem in that code and it can't be compiled and bundled together, our application won't load and we'll get a compile error. So let me grab the React code and show you. So here is that React project. I'm in the index.js file, and if I tried to import something from the wrong path, like I tried to import app, which is in this components folder, and I'm in index, this path is saying look for app in the same directory as index, I'm going to get a compile error. Module not found, cannot resolve an app in the current directory from this path. So it is literally telling you, you looked for this in this path, it doesn't exist there. You might want to look at this again and try and fix it. And our compile errors are going to stop our application from running. And when we're using the React development server, it's actually going to pipe the errors to the browser window, which is helpful for us to see really quickly that our app is crashed. So let me fix this. Compile error goes away, but compile errors can also be generated from JavaScript syntax errors. So if I forget the comma here, I'm going to get an error that tells me on line 5, column 25 of index.js, the parser that was going through our code, parsing it and trying to compile it, found an unexpected token, and it expected a comma at this location. So it's actually, even though these error messages are maybe frightening the first time you see them, it's actually giving you a lot of information to help fix your bug. So I'll throw a comment back in here. It compiles again. With compile errors, the thing you want to do is make sure that you're checking your console, your terminal window often to make sure that there are no compile errors. The next class of errors are called syntax errors. So these are when you have invalid code. You haven't written code correctly, and the JavaScript file cannot be run by the parser in our compile step, and it can't be run by the browser, by the JavaScript engine inside of the browser. So we just saw that inside of the React project when I forgot a comma. That was a syntax error, and that crashed our compiler here. But I want to show you it in a regular HTML, CSS, JavaScript project too. So what I'm going to do is grab the, that's the broken version. Let's grab the non-broken version of our Pokemon application here. So a syntax error would be if I made a mistake in coding, like I forgot a curly bracket and I looked in my browser, that page can no longer be parsed and run. That JavaScript has invalid syntax, and we're going to get some kind of error in our console window saying uncaught syntax error, unexpected token const, tells me what line and what file. So index.js line 4, it didn't understand this token, this word, because of that missing curly bracket. So the error will show up in the console in your browser, but it will also show up here in Visual Studio, which has a linter installed and a parser installed. So here I can hover over it and I can see that I'm getting this problem that declaration or statement was expected, or I could open up the problems section and look at the message here. And you're going to get sometimes a different error message in Visual Studio versus in the browser. So sometimes it can be helpful to check both if you're having trouble. So let's fix that. And as soon as I fix my syntax error, the page loads again. So that's syntax error. We've made a mistake somewhere in our code. Our code can't be processed and run by the parser if we have a compile step, or by the browser if we're running our code directly in the browser. The third type of error is a runtime error. So we've used the proper syntax, but when we get to a specific part of the code, we have done something that's invalid, like trying to access a variable that doesn't exist. So I'm going back to my working version here, and let's say I know that this function is running, add title to page, and I try to do something like button.add event listener. Click. So this is technically valid JavaScript. There is no problem showing up in here. And if I go back to my browser, the error is happening when we get to that line of code. So we're getting uncaught reference error, button is not defined. It's telling us index.js 55. So that gives us a clue where this went wrong, and we can see we haven't declared button anywhere in this file. There is no button variable. So this would be a runtime error where the syntax is fine, like this syntax is properly formed for declaring a function. I've got all the right curly brackets, all the right opening and closing parentheses, but I have run something on a variable that doesn't exist. So runtime error, those are where it's really useful to have your console window open as you're working. And then the last type of error, sometimes the most hard to debug, is a logical error, which means your code does not crash. There is no error, there's no compile, syntax, or runtime error, but you have done something wrong logically, and your code doesn't do what you expect. So an example of that would be with our React application. I have a component that is trying to do a calculation of taking some input, another input, and then displaying the results. But if I look at what's happening in the browser, 100 plus 0 is giving me 1,000. 100 plus negative 200 is giving us 100 minus 200. So there's no error, there's no compile error, there's no console error, but the thing that's happening in our browser is not the thing that we expect. So those are the four general categories. We have compile error, syntax error, runtime error, logical error. And we want to keep those in mind, because having those in mind will give you clues as to what debugging strategies you should use to solve your error. So let's go through the steps together. I've got this debugging checklist that you should keep this handy as you're working on your projects. These are the steps to go through as you hit something that doesn't work in your project. So the first step is really don't stress out. Again, errors are part of programming, so you embrace them. If you lean into them, you'll be able to solve your problem. But if you just stress out and freak out, this process of debugging will be much harder. So just accept that this is part of the process. The more errors that you solve, the more confident you will be in your debugging skills, the stronger your debugging skills will be. And then when you hit errors in the future, you'll be like, yeah, I got this. I know I've solved a ton of bugs before. I can fix this one for sure. So we're going to go through the process for this HTML, CSS, JavaScript project, which is not React based, but the same ideas apply to our React projects. And the first thing we're going to do after not stressing out is check for errors. So let me close this one and let's get the working or the non-working version up. So I've got my project here, and we want to check for errors. We want to check inside of Visual Studio. We can see that there's a problem here. So something is wrong with our syntax. And we can also check in the browser by opening up the developer tools and looking in our console window. And we're actually seeing that we've got two different errors that are being given to us. So we can start with either in terms of debugging. So let's start with index.js line 10. So if I scroll up here, index.js line 10, the error that we're getting, uncaught syntax error, identifier string has already been declared. So identifier here is the name of a variable. It's giving us which variable here, string, and it's telling us the problem is that it has already been declared. So we want to spend a minute reading that error, thinking about where it is, and trying to parse what is being told to us. And in the beginning, these messages will seem obtuse, but they are written very technically and have specific information in them. So if we didn't know what this meant, what we could do is Google search it if we're lost. So identifier, we would want to remove the pieces of our error message that are specific to our code. And we would want to include keywords like JavaScript as we're doing our Google search. And you will often end up with people who have had similar errors along with some explanation. So you're going to have to do some reading and some digging here, but you can take your error messages and use them to Google. So in our case, let's say that we understood this. Identifier string has already been declared. Line 10, I'm seeing this variable. It is telling me this is a problem. I can't declare this variable string. So then I would start looking, well, maybe this has been declared someplace else, and I'll start scanning up. Even if I don't necessarily know what all of this code does, since we haven't walked through it, I can still look for variables like, okay, here's one that's not named string. Here's one that's not named string, not named string, not named string. Aha, our parameter is called string. So this variable, we are trying to redeclare it here, which is not allowed. So instead, what I can do is change this variable name. So this function is capitalizing the words in a string. And here, what I can do is call this maybe capitalized string. And make sure to return that. So now I'm no longer redeclaring this variable. I've got a new variable that I'm storing and using here, and that syntax error should be fixed. So if I flip back to my browser and check out my console, I can now see a different error. So unexpected token const, index.js line 20. And we go through that same process. Maybe we don't know what that error means, so we Google it and we start to pick apart the pieces. But if I look at line 20, it's telling me when it reached this part of the JavaScript, it does not know what const means in this context, which, you know, that line of code seems fine to us, right? So we want to start looking around that line of code and see if there's an error someplace else. And so if I flip back to function, I can see, this line doesn't match our other function declarations where we have a opening curly bracket at the start. And actually, if I were using my editor and using that error that we got here and double clicking on it, it's taking us to this curly bracket and telling us that this was unexpected, that there was a declaration or statement that should be here instead. So both of those would be cues to us to know that we are missing a curly bracket there. If I flip back to my browser, I no longer am getting syntax errors. I'm getting something called a type error. So I've actually fixed the syntax errors in my project. So let's look back at our checklist here. So we went through the process of checking for our errors inside of Visual Studio, inside of Chrome, and we were able to identify what type of error it was. It said syntax error. So we were able to walk through trying to solve that to get any code running in the browser. And we went through this process of reading the error messages. Even if we don't know all the words, we can still try and piece them together. We went through the process of Googling and making sure that you have keywords when you're Googling. What I want to do now is look at this locate and isolate step. So if we have errors in our project, sometimes what is useful to do is try to comment out all lines of code until you're back at a working state of your application. You have no errors, and then you can reintroduce things piece by piece until you have gotten back to your bug, and now you know what line of code is causing that bug. So what I want to do is apply this process to our project here. So I know I no longer have syntax errors. So what I'm going to do is just go ahead and comment out all the code in here, which should mean that if I go back to my browser, this is working. And if I come down to the end of my JavaScript file, I can console.log and see hi, I'm working printing out. And what I can start to do is uncomment chunks of code until I find the first place where a bug reveals itself. So if I'm looking through the code, I can see that there's an import at the top. There are a couple of function declarations. And then down at the bottom, we have the actual code that starts running things. So I have a root element here that is being pulled with document.querySelector. So I'm going to uncomment that out, try running it. Great. We still see our message printing out. Nothing is broken yet. We have not gotten to that runtime error yet. So then I would start adding these functions back in. So I can see I'm calling add title to page. So I want to go ahead and make sure that that function is defined. And what this function looks like it's doing is grabbing that root element and setting its inner HTML equal to or appending this h1 to that inner HTML. So if I save it, I flip back, aha, we've gotten to our error, or at least one of our errors here, and it's telling us uncaught type error, cannot read property inner HTML of null. It's telling us it's at index.js line 54, and then it has what's called a stack trace. So it's telling us that it encountered it at line index.js 54, which this function was called from index.js 61. So it's telling us that this line of code in the stack trace called this function, which introduced the error here. So we can apply our process again of reading this error. Cannot read property inner HTML of null. So what that's telling us is that inner HTML, when we were saying .inner HTML, we thought we were talking to a variable that was filled in with an element from the page, but instead we're getting null here. And we can verify that using some of the other tools that we have, like console.log. So I could print out this root element and see what it is in the console. Null, which is not what we'd expect. We would expect that it would be pulling an element from the page and storing it into this variable. And because we have a runtime error, we know that we can insert our console.logs up until that runtime error, because when this line executes is when the application crashes. So this line will run, add to page runs, it crashes, and we no longer see our console.log, hi, I'm working. But if I moved it up here before that add title to page, now we would see that printing out. So you can use this to kind of identify where crashes are happening, throwing in console.log. We'll talk about the debugger in a second. So root element, we know that this is null. Then we might start looking at the documentation, like, oh, document.querySelector The document method query selector returns the first element within the document that matches the selector that we passed in. If no matches are found, null is returned. So we're learning from this documentation that when we get null back from query selector, that means that it couldn't find something on the page. So what I would want to do then is say like, I am looking at this selector that I passed in, and my index.html, I can see something on the page which has an ID of root. If I compare that to my selector here, I forgot my hash that indicates that this is an ID of root inside of query selector. So if I save it and I run it, we now actually have something working on our page. We have that heading printing out with our hyperlink to the API. So this process of locate and isolate is really helpful because we can start getting pieces of our application working again, and then we end up identifying specific areas where bugs are occurring. So if we wanted to continue with this process, we would then, take more chunks of our code, uncomment them, figure out the bugs, and fix them until we have uncommented everything and we have a working state with no bugs. So for our application, let's just get everything running again and see where we are in terms of errors. So I'm going to grab everything, uncomment it, and I can get rid of my console.logs here. And check out my project. And we've got a new error that is a runtime error. And we can tell this because it is uncaught reference error, it's not a syntax error, and also because part of our code has run. So it ran until it encountered that runtime error. And it's telling us that data is not defined. It's telling us it's on index.js line 20, which is inside of build Pokemon HTML, which was called from add Pokemon to page, which was called from index.js line 62. So if we go to index.js line 20, it's telling us that this variable has not been defined anywhere. And if we follow that stack trace that was given to us, it's telling us that that was called from add Pokemon to page on line 43. So this function was invoked from this function on line 43. So what we could do is two things here. We could start console.logging everything. So print out our variables. We could see what Pokemon data looks like, which is the thing that we're passing into this function, and print out a whole bunch of variables to get information about what our application looks like. So here I print out something before that error occurs. I can see, here's Bulbasaur's information. Here are Bulbasaur's abilities, moves, name, sprites, types. So we've got some data that should be able to be used to render Bulbasaur to the page. And we could keep going console.logging, but I want to introduce to you the debugger. So after locate and isolate here, another step in your checklist is using your developer tools. So console.log, that's what we just talked about, where you can drop that in to check the state of variables and watch your code as it executes. This is really helpful early on, and is also helpful if you need to watch the state of your application in real time. Like you need to be able to see a bunch of console.logs while someone's interacting with your page. But in general, the debugger is going to be a much more helpful tool when you're trying to figure out what's going on with your code. So the debugger we can use in two ways. There's a debugger that's built into Chrome, and there's a debugger that's built into Visual Studio. So I'm going to show you the debugger that's built into Chrome. So when I go to my page, I want to make sure that I open my developer tools and that I am on my sources tab here. When you load it up, you probably won't see anything in here, or you can close all of those tabs to get the default instructions showing up. Which tell you that you can use Control-P to search for a file, like I can search for index.js or pokemon.js. I can also use my sidebar to inspect the files, so they will be organized by the source where they came from. So some of the files are coming from fonts.google, since I have a Google font loading here. But also we have our localhost port 5500, which has our index.html, which has our JavaScript, our index.js, our Pokemon.js, our CSS. So we can open any of these and start inspecting the code. What I want to do is close all of them other than index.js. And I want to put a breakpoint in here so that we can start our debugger running. So on any line of code, I can click to toggle a breakpoint on and off. And you'll see as I click, that breakpoint is showing up in a list here that can also be temporarily disabled with this checkbox. I want to come down here to our first line inside of this file, root element. And if I refresh the page, the debugger is going to kick in when it hits that breakpoint. So this JavaScript is executing line by line until it hits line 60. And we are now at a breakpoint where execution has been paused. Nothing is rendered to our page yet. And you can see it says paused in debugger here. So when we're paused in debugger, we can do a couple of things. We can look in our sidebar to see all the variables that are in our scope. I can see all the functions in index.js. And I can see my Pokemon array, which is this data that's being imported on line 1. That data has the abilities, the name, the ID, the height, the moves, the sprites, the types for 15 Pokemon. These are pulled from the Pokemon API and are stored in this Pokemon.js file as an array. So I can see that variable. It's currently defined by the time we've hit line 60 because the import has run and we've gotten that. And you can see that as I hover over variables, as they've been filled in, I can see their value. So here I can hover over it and see all of the elements within inside that array, expand them. And I could do the same thing down here. I can see document. This is a object that represents the document on the page. It has properties like the body, which if I hover over that, I can see that highlighted on the page. I could click on it to head to that element in my Elements tab. So we're paused right now. Nothing's running. I'm just kind of able to inspect different aspects of my code at this point. And so from here, what I can do is use the controls up here to control the execution of my code. It will allow me to run line by line and watch the code. If I use step into or F11, if I hit resume, that will continue running the code until the next breakpoint. So if I click resume, that is going to run the rest of the code until it hits an error or finishes executing because there are no other breakpoints in our code. So if I refresh the page, I can get back to this paused spot in our debugger. And step over and step out will allow us to sort of control the flow in a more fine-tuned way than step into. We're going to start out just using step into. So I'm going to hit F11 or click this button to watch the execution line by line. So now that I've left this line of code, I can hover over my root element and see, oh, we did get an element. And as I hover over it, it is highlighting it over in the HTML. So if this had been the wrong selector, I would hover over this and see null or undefined, which would have helped us solve that problem we were having initially with our project. If I hit F11 now that I'm on add title to page, it is going to head into the add title to page function, and I can see that this line of code is going to start executing. If I hover over the inner HTML at this point, it is telling me that it's empty. As I run that line of code, I could hover over it, and now that it's done, I could see, oh yeah, all of that has been inserted into the inner HTML, and that has now rendered to the page. So I'm going to keep going with F11 or step into, and we're back down here. So add title to page is finished, and now we're going into add title, add Pokemon to page. We get down to this, and now I can watch as this loop executes. So I can see that my list string is initialized to an empty string, and then my loop, I am watching it run, where if I hover over I can see that it's 0 currently, and I can see I've got Pokemon.length is 15, which is going to control when this loop finishes running. I can also see these variables over in my scope. So currently Pokemon data is undefined. But if I hit F11 to go down one line, we can see we went into our Pokemon array and got the 0th index thing. So now I have Pokemon data, and Pokemon data is for Bulbasaur. It's the first Pokemon in that array. It's grass poison type. So I've got all of that data. And as I let this execute one more line, our console.log runs and that data shows up in our console. And then we can see that we're going to call build Pokemon HTML. We're going to pass in that data. Step into, which takes us into the build Pokemon HTML function. We can see that data's there, and then hit F11 one more time, we crash. So we've got an error here, data is not defined. And in my browser, I've now been kicked over to an extension that I have installed. So if I hover over this file, it's telling me it's coming from a Chrome extension with this ID. And if I look down here, it looks like my ad blocker. That's the extension that I'm now in, which has some code that is handling errors, checking for errors. So sometimes you'll end up getting stuff running in your browser that is distracting because it's from your extensions. So you could run your code in a private tab, or you could use the debugger inside of Visual Studio. At this point, I know where my problem is. So to get back to where I want to, I'm going to put a breakpoint on line 20. I'm going to refresh my page, and I'm going to hit resume after we hit that first breakpoint to get back to line 20 here. And I can see data, this variable is undefined. There is no variable called data that we've hit since we just watched all of the code execute from top to bottom. Pokemon data is the variable that looks like we want to use here. This is the thing that has an ID, has a name. So when we're pulling out ID, pulling out name, that's what we want to fix. So I'm going to stop my debugger by hitting resume, flip back to my code, look at my build Pokemon HTML where I was calling data. And in all of these places, I'm just double clicking with holding control to select all of them. I can now type in Pokemon data to fix that error. So now each line of code is using the right variable. It's using this variable that's been passed in. So I am going to get rid of my breakpoints here by clicking on them to remove them, refresh the page, and we can see, no more errors in our console. Something is rendering to our page, but it is a bunch of gibberish that says undefined, 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 undefined. So we've got a couple of options. We could turn to our console.log and just start printing out all the variables to make sure that they work and find the place where this undefined is coming from, or we can continue to use our debugger. So we're going to turn back to our debugger and go to our first line of code again. I'm going to refresh the page, and we can trace our code step by step. So now I can introduce some of these other controls here. So step over, if I'm using step into next function call, when I get to a function, like right now I'm at this invocation line of add title to page. If I click step into, I'm going to head into that function and watch that function execute line by line. If I hit step over next function call, that will just let that function run without me inspecting those lines line by line. So we can see that displayed to the page. So that function ran without us debugging each line within it. If I refresh my page and let's go into that function. If I use the step out of current function, that means I'm going to go up a level in terms of my call stack, in terms of the sort of sequence of functions that have been called here, and the rest of that function will execute. So here I stepped out of that add title to page, all of the rest of that ran, and it displayed on the page. So step over and step out will allow you to have a little bit more control over where you are in your code and get to different places faster. There is also inside of the developer tools the ability to right click on lines of code and click continue to here. So if I wanted to skip over add title to page and get directly to add Pokemon to page, I could continue to here and add title to page is going to execute. So we've got a couple of different ways to jump around our code. So let's continue that debugging process. So I'm at add Pokemon to page, and I'm going to use F11 again to start watching, and let's see where that undefined comes from. So I've got this list string, which if I look down a little bit further, looks like it's being put into our root element, wrapped with UL around it. So I can F11, and this loop is going to run. So console.log should run. We get our Bulbasaur printing out. We go into our build Pokemon HTML. If I run through here, and maybe I'm not going to watch this capitalize run, so I'm going to step back up. This is a function call. Maybe I don't want to watch that run. I'm going to step over again, step into, and I can look at some of these variables now. So I can see the ID is 1, Bulbasaur, capitalized name is Bulbasaur with a capital B, height is this big number, types, grass, comma, poison, front image, back image, and now we're on this HTML string line. So if I hit F11, I can look at that HTML string. So I look like I've got a list item with that Pokemon information embedded in it. And hit F11. I can look at this Pokemon string. That's undefined. So I wanted to capture that string that we just saw inside of build Pokemon HTML and put it in here so that we could add it to this list string and build up a series of list items in string form. But we're getting the word undefined. So maybe I'm going to hit step over to just let this run without going into build Pokemon HTML again. And I can see, oh, undefined. So keep going. Undefined. And if I resume, that's where that undefined is coming from, is that this string that I thought had some HTML string that I was adding together is actually undefined. So I've been able to identify where the root of that problem is. So if I flip back to my JavaScript, I can see that this function builds an HTML string, but it doesn't ever return that. So when we return that HTML string, that means that it ends up here on this side of the equation, and we can put it into our Pokemon string and add it to our list string. So if I get rid of this breakpoint, and I'm going to put a breakpoint here, right after build Pokemon HTML runs, I can see my Pokemon string is now being returned. It's not undefined. I've got Bulbasaur in here. And then if I hit F11, it gets added to my list string. And if I hit resume, that's going to hop me to the next time we get to this line of code. And if I hit F11, we can now see two list items. We've got Bulbasaur, Ivysaur. Keep going. F11. Venusaur is added. So we've got 3 Pokemon. So I'm going to get rid of this breakpoint. Let's just resume our code and see. There we go. We have gone through this process of looking at our errors, isolating them, using console.log, debugging, and we finally have an application running. So we got a lot printing out to the page, and it looks like we have one more logic error. I don't think that Venusaur is 6 million feet tall, and it looks like we've got something happening with all of them that is making the height really, really big. So again, we go through this process. What type of error are we encountering? Well, there's no error in our console. There's nothing preventing us from running this. So that is a logic error, again, where we've done something that is technically valid JavaScript, but is not giving us the right thing. So we've made a mistake in our coding. So then what I might do is do the same debugging process. You could either use console.log or use the debugger. I'm going to argue that the debugger is usually going to be the faster tool for you to use. And what we can do, instead of triggering it from our sources tab, I'll show you another way to trigger it. If we go to our JavaScript and we look at where height is calculated, if I put in this line of code, debugger, what that does is instruct Chrome when we hit this line of code, pause execution, go into debugger mode. So it's like inserting a breakpoint from your code. You can see as I refresh the page, we're now at this debugger line, and we can see what's going on. So we're pulling out the height here from Pokemon data, which is in decameters, which is coming from our Pokemon API, and we're using this function to convert that to feet so that we can display it in imperial units. So I can use my controls again to watch the execution here. So I can see we're going into this function. We can see that our decameters is passed in, and then we do this conversion. Decameters times this number. Something looks weird there. We're getting a huge number. So the logic error here is we could Google search decameters to feet and look up the conversion. There's our number, except that it should have a decimal place at the start. So it should not be 300,000 something, it should be 0.3. So we can flip back to our code and solve this problem by doing 0.328084. Save it, check it out in the browser, and it looks like we've sorted everything out with this project. We've gone through all of the syntax errors, the runtime errors, and the logic errors, and got it working. I want to take a quick interlude to show you the Visual Studio debugger and how to set that up. You can totally work with the debugger that is inside of Chrome. The advantage of using the Visual Studio one, which we'll see in a second, is that you can insert breakpoints directly in your source code by clicking here in the gutter next to the line number, and you'll get a Chrome instance that pops up that doesn't have any of your extensions installed. So you kind of have a cleaner environment while you're working. So you need to install an extension for this to work. So you need to have the Chrome Debugger, Debugger for Chrome extension installed, which adds to Visual Studio the ability to use the debugger that comes with Visual Studio with a Chrome instance. And since we're running web projects, we need that. So once you have that installed, you can go on the sidebar to the Run tab, and this allows you to set up what is called a launch.json file, which helps you configure how this project should be launched. So I'm going to create a launch.json file. I'm going to choose Chrome so that I open in Chrome. And this configuration file, you can learn more about the information in this configuration file, but it's telling us that it's going to launch Chrome against the local host. And specifically, here's the URL that it's going to try and launch Chrome with. This must match our project. So here we can see we're using live server. Down at the bottom, it's 5500 for the port. So I would need to change this to be configured to run on the right port. And if we're using Create React App, we're on a different port, so you'd have to configure it to have the right port. Here, we have to make sure that live server is running before we actually try and run this. And then we can click play to get a new Chrome window popping up that will allow us to pause on those breakpoints. So if I want to, I would come back to index.js and drop in a breakpoint somewhere in the project by clicking here, and then I can launch Chrome. And as soon as it hits that line of code, it's going to drop a breakpoint in. We're going to be able to see on the sidebar our variables at any moment in time. We can also hover, same way that we were doing in the browser, to see the state of different variables. We can see our call stack over here, like we could in the browser, and we have our controls. So we have step over, step into, step out. We have restart, we have stop, and we have resume or continue. And hotkey here, F11 is the same for step into, so I could do F11, step in, watch that execute, and then if I flip back to my Chrome tab, we now have that executing up here. Let's see, what else should I show you with this? So if I'm gonna stop this, and let's add a console.log here. And start running it again. we have a console window inside of Visual Studio. So View, Debug Console, or Control-Shift-Y, and we will see the output from our console inside of Visual Studio. So we could also see it in here. We could open up our developer tools. This is a Chrome tab, so the same things that you have available in our regular Chrome, you have available in this Chrome. This is just a clean Chrome tab that is spawned by Visual Studio. So we can see it printing out here, or we can see it printing out here, and we can do the same stuff. We can step into, we can watch a bunch of code run line by line. Let me step out, and let's step out one more time. Watch add Pokemon whoops, that's the wrong one. Grab here. Our Pokemon listing has finished printing out here. We're still in our debugger, so let me just resume, let it continue running, and all our images load in. So either of these will work. You can use your debugger inside of your normal Chrome window, or you can set up your project with the launch.json and use the debugger and breakpoints within Visual Studio. When you do that, you'll have this launch.json file in your project in a .vscode folder. So if you're using version control and Git, you'd probably want to hide that, add that to your Git ignore so that it doesn't end up clogging up your version control software and your history for your project with files that aren't really relevant to the source code of your project. So let's look back at our list, our checklist here. So other things, we've covered these up at the top: not stressing out, locating and isolating, developer tools, reading error messages. I want to talk about these last three quickly, and then we'll take a look at React debugging, which will be the same process. It's just there's an added tool we can use. So the first one here is reaching out. So you can always reach out to your peers via Teams. You can reach out to the IM tutors, instructors. You can post on the internet too, to forums like Stack Overflow. And actually this process of just writing up and trying to articulate your problem clearly will help you question your assumptions and see your project in a new light. So this will often lead to you solving your project or solving your bug that you're hitting. So that's why I also link this rubber duck debugging. And if you look at my desk, you would see a rubber duck that I keep on my desk at all times. And rubber duck debugging is simply you take that rubber duck and you try to explain what your code is supposed to do, and you do it in detail line by line. And as you are doing that, you will often realize what's going wrong, because the act of just holding up a silly little rubber duck will put you in a different mindset for thinking about your code. You're thinking about explaining it rather than writing it, and that will help you find bugs, reveal errors that you weren't seeing when you were deep in the details of trying to write your code. So it sounds silly, but it also works. Next here is taking a breath and taking a break, which is a very valid strategy in programming. In other domains, sometimes you get so deep in the weeds on a problem that you're essentially just blinded to the big picture. So getting up, walking away, taking a nap, focusing on something else, all of those can help you reset your brain so that when you come back to your project, you have fresh eyes, and that syntax error that you couldn't see before will suddenly become obvious because you're looking at it with fresh eyes. The last link I have here is putting on your scientist hat. And there's an article that talks about the scientific method of debugging, but essentially what you're trying to do is look at your problem, form a hypothesis about what's wrong, test it, and that test will give you information. It will either tell you, oh yes, that was the problem, or no, that wasn't the problem, or inconclusive, I need more information. And what you do then is repeat that process. So each step of the way, you are learning slightly more about the problem, you are testing your hypotheses, and eventually you will get to the root of the problem. Okay, so let's wrap this up with looking at a React project and what debugging looks like in React. So I've got my React project. Let me close down all these tabs except for the React project tab. So I've got this project loading here, and I've got a couple components. I have a timer, I have this click buttons component, and I have my app, which has this sort of equation setup in it. So I've got the calculator, which is the equation. Looks like something funky is going on here where it's not doing the math that I expect, but it looks like my timer is working fine and my click counter is working fine. As I would look at this project, I would try to go through the process of identifying what type of error I have, since there's nothing in my console here or in my terminal window, and there's nothing in my browser console printing out as errors. I know that I have a logic error, that this means that I have valid JavaScript syntax, but I'm doing something logically that's off. What I would do is go through that isolation. Like, I know my error is localized to this calculator, so maybe I'll get rid of this timer, I'll get rid of these click buttons by commenting them out, so I can just focus on the calculator. We'll see in my terminal window that I'm getting warnings. I'm not getting compilation errors, but it's telling me that I have got some variables that were never used. So I imported some things up here, but never used them. So we can ignore that safely. These warnings were generated by us commenting out these components temporarily. But if you see other warnings, those are worth looking at to see if maybe those are leading to some of the problems, is that will tell you about things like unused variables, and it's very uncommon for you to actually want an unused variable in your project. So with this project, we can do the same thing we've done with other projects, is we could console.log to print out the value of different things to try and figure out what's going wrong, or we could use our debugger to check out the value of different aspects of our project. So what I might want to do is I've got this code here. Let me collapse the sidebar so that we can see more of it on screen at once. So this section here, I have an input and its value is set by this state, number 1. I've got another one whose value is set by this number 2 state. I've got on change handlers for on number 1 change, which is this, on number 2 change, which is this, and they just look like they're pulling the value out from our event and using it to set the relevant piece of state. So this sets number 1, this sets number 2. So what we might want to do is take a look at the value of our state at any moment in time. So maybe what I'm going to do is throw a debugger in here. And this is going to cause the debugger to run anytime our app is rendered or re-rendered. So the first time the page loads, app has to be called to be rendered for the first time. So we're going to get it paused there. And then anytime our state changes, React is going to re-render app because it knows that these state variables that we've declared inside of app are changing. So what we can do now is go back to our browser, open up our developer tools, refresh the page, and with that debugger, this is the first time the app renders. I can hover over number 1, number 2, they're set to 0, which sounds right, and then I could hit resume to get out of that first render, and then I could modify something to trigger a re-render and get the debugger pausing the application again. So maybe I'll add a 1 here, and we're now back at our debugger, and I can look at the state of the application now that we have changed something. I can look at number 1. Aha, number 1 has a string 10 instead of a number 10, and number 2 is the number 0. So then down here, when we do number 1 plus number 2, we are getting 10, the string 10, plus the number 0, which would be 101. And we can actually use our console to inspect variables here. So I could say number 1 plus number 2 to simulate that line of code that is in our JSX and see, aha, that's going to give us 100. I might have said that wrong a second ago. But yes, that will give us those numbers concatenated together as a string instead of added together as numbers. And if I let it run, we will see that print out. And if I went ahead and changed something else, I would trigger the debugger again, and I'd be able to look. Number 1 is 10, number 2 is 20. Do the same line of code again 1020, 1020. So we've identified our problem here. And then we could go fix the code, which would amount to, we need to make sure that this is a number. And I'll do a little bit of extra logic here. So I'll say if the value is equal to an empty string, let's go ahead and set number 1 to be 0. Otherwise, let's go ahead and set number 1 to be parse int, or let's use number.parseInt value, and we're specifically saying that this is base 10 as the second parameter here. And we can replicate this logic here and use set number 2. So if I get rid of this debugger and come back to my code, let it execute again, refresh my page, and try adding 2 numbers together, now the code is actually working as expected. I can see a warning. Looks like I used double equal sign instead of triple equal sign, and generally encourage you to use the strict equality check, not the less strict version. So that warning should go away. But our code should still be working now. So we did our localize and isolate by removing any components that we didn't need. We can add them back now and see our full application is working as expected. And I'm going to show you what these borders that are showing up are in a second. So that's pretty much it for debugging inside of React. We are now working within a framework. So you saw that when we were using our debugger, sometimes we're going to like put the debugger in a specific spot rather than watch the code execute from start to finish, because executing from start to finish means you would be debugging through a lot of React source code. So you kind of want to put your debugger close to the thing that you want to debug. So here I was putting it inside of my app so that I could look at the state of the app at any point in time. So the last thing that I want to show you here is the React Developer Tools. So this is a Chrome extension. If you look for React DevTools, one of the first links will be the Chrome extension for React Developer Tools. When you install that, you end up getting an extra set of tabs over here in your developer tools. If you hit the little more icon here and you click on either components or profiler, these are the things that get added from your developer tools. So the profiler allows you to record your performance and start checking out how your components are doing over time. So if you have something that's going really slow, this can be useful to help profile it and identify what's slow. But the components tab is probably where you're going to start. The components tab is going to be like our elements tab, where we could see the HTML and hover over elements, except that the components tab allows us to see our components, the JSX components that we defined in our code, our React components. So I can see my app, I can see my timer, I can see my click buttons, and then each button within inside of my click buttons. When I click on any of these, I can see their state and their props associated with it. So my timer has no prop associated with it, but I can see one of my hooks here, and I can actually modify the value to see what it looks like. So now I changed the state, jumped it up to 1000, and it continues running with that state as the starting point. You have some options up here, like you can inspect the DOM element that's associated with it. You can log the component to your console and see the hooks that it's using, the nodes, etc. You can click on this to see your source code for that component. And one thing that I should mention here, if I close all of these and you're trying to use your sources tab here, you're going to have your minified code. So that output code that is bundled, like when we did our build and looked at our build, that's what you're going to see here. So you're not going to see your files like you would expected until you actually go into this source folder, which has your folder, you have your source. So inside of here, you can get to your components. Like if you wanted to add a breakpoint to your click button from the browser, you could do that here. And then if I rerun it, we will hit that breakpoint when the click button is running. The other way that you can find them more easily is close all these down, use Control P to open a file. So you, hit Control P, and maybe I want to look at my timer, and there's my timer code. So there's components that you can jump to your source code from here. You can modify your state. I could also modify my props to see how my components react to those new props. So here, maybe I want 10 click buttons instead of just 3, and I've changed that num buttons prop on this click buttons. And now I can run this. The other thing that I want to show you here is under settings, I have highlight updates when components render, and that's what those flashing boxes are. So what that's telling me, if I turn that on, is which components on my page have triggered re-renders. So my timer every second is updating state, which means that that component, React knows it needs to re-render every time the state changes. But that means that none of my other components have to change. So my calculator up here only changes if I touch the calculator. This calculator sits in my app, so when the state changes there, all of these components will re-render. So my click buttons re-rendered with the default number of props that app is specifying. Let's get that back. So let's say we have 10 here. My click buttons, if I click on one of these, it's changing the state of the individual button, and then it is also changing the state of my click buttons up here, which you can see has some state associated with it to store the total number of clicks. So every time I click it, it's rendering click buttons, all of these children, but clicking these buttons doesn't re-render my calculator or my timer. So using this settings highlight when components render can be really useful if you're like getting a bunch of components on your page that are re-rendered for some reason. You can start to inspect why your components on your page are rendering. Okay, so that's it for debugging. This process that we're going through, it is a general process. This is what you would do regardless of what programming language you're working in. There's some specifics here for the build steps, the compilation steps for JavaScript using Create React App, and some specifics here for how to open up the debugger and open up the developer tools. But generally, this is a problem-solving process. So what you want to do as you're working on your projects, keep this debugging checklist handy until it becomes second nature. And then when you ask for help from someone, including when you ask for help from me, tell me what steps you've gone through. The more work that you do to figure out the source of your problem, the more likely you are to get help. So if you've gone through this process of reading the error messages, you've located and isolated your error, then when you post to someplace like Stack Overflow or a forum, you can say, here is a short snippet that generates my error. Here's my error message. I'm stumped. I can't get any further than that. And then it's really easy for someone else to come in and be like, here's a little test snippet that I can run. I can see the error. Here's the advice that I can give you. As opposed to if you just upload a zip of your project with nothing sort of isolated, you've got multiple components, you've got all of this stuff. It's really hard for someone else to jump into that project and help you with your error. So this will both improve your debugging skills going through this process, but it will also improve your ability to get help from other people if you go through this process. So I'll leave it there. Make sure you go through this process, you practice this process as you're working on your projects.